A very good evening to everyone, and a warm welcome to the sixth session of the FFE Technical Series. I'm Krishnapriya from FFE, and it is my pleasure to introduce today's distinguished speaker, Mr. Madhusudan Sahu, Engineering Manager at SAP Labs India Private Limited. And we are delighted to have him back with us once again. Mr. Madhusudan brings with him over 19 years of rich experience in software industry, where he has successfully contributed in various roles including engineer manager, architect, product owner as well. So his expertise spans multiple domains such as e-commerce, ERP, banking, and finance, where he has played a vital role in designing robust and impactful technology solutions. At SAP Labs, he currently leads engineering teams, manages operations, and drives platform focused initiatives that enhance efficiency, scalability, and innovation. So, his technical proficiency covers a wide range of technologies, including Java, AngularJS, Spring Boot, Kubernetes, and generative AI as well. Along his corporate contributions, he is a strong advocate for innovation and developer productivity. He and his team actively contribute to open source projects and build platform capabilities that improve the overall developer experience. Today, he'll be sharing his insights on test-driven development, a critical practice in modern society that ensures better quality, code iterations, and great confidence in development. With that, please join me in giving a very warm welcome to Mr. Madhusudan Sahu. Over to you, Madhusudan.
So, hello everyone. I'm going to cover this test-driven development in SAP. I have given this session a couple of times for our expert curriculum. So maybe I'll cover this session with you guys on very high level. Obviously, this is some hands-on session also, but here we'll not do all these things. So it is a brief overview about this. So let me start. So basically, why do we need a test-driven development? So generally, whenever we are developing any software, there is a cost involved on that software, and this software is having some life cycle. Maybe some millions or billions of rupees are needed to run that software. So throughout the life cycle of the software, mainly 80% we are spending on the maintaining of the software, and that's why we focus on the testing. So, like I can say, maybe 20% cost is needed to the development of the software, and 80% is for the running the software or maybe maintaining that software. So that is the cost, and that's why we need a testing and to reduce that cost. And as part of that, there are four different kind of testing are there. First is a unit testing. When we are doing any development, software development, the unit testing is done at that time. So it is parallel with the software development. Then integrated component testing is there, which is let's say maybe I am calling the third party API and then also storing the data on the database. So then we have to connect with that system and call that. That is called integrated system. Sorry, integrated component testing, or maybe two or three component together. And then system UI testing. So basically from UI, I'll send a request and then it will go till end. That is called system UI testing. And the fourth one is a exploratory testing. That is basically manual testing. So some tester will be there in a company. They will test couple of scenario. So as you can see the graph, what's wrong? Okay. So as you can see the graph over here, when we are at the bottom layer, effort and test coverage, you can see, right? So here, we need a more effort if we want to do this kind of testing. We need a more effort initially, but the test coverage will be more. Sorry, effort will be less and the test coverage will be more. Whenever we are going up, so to test each scenario, we need more effort. So basically, because of that, cost is increasing, and effort is also basically if we want to test all the scenario, then effort is also increasing. So that is why when we are going up, cost is getting increased. So that is why we are focusing more on unit testing. If we will focus more and we'll cover most of the scenarios, then our cost will reduce. And that is why we focus on the test driven development. So, uh, so basically, why do we need to write a test-driven development? So I have covered here one scenario. Let's say, why do you need this? The advantage of doing this. So basically when we are running the test, when we run the integrated test, so the another one, the scenario which is here, the second test, if we are going with this scenario, so basically what happened, we run with the real environment. So as you can see, if I'm doing a integrated test, so there is a components are there A, B, C, D, E, F. So let's say maybe this is a controller, this is a service, this is one of the database, and this is maybe some third party API, maybe Google Map or Google something, and then this is another component, and finally database. So this is a integrated testing. So all the components are touched over here. Let's say this component D is failed over here, then my test is breaking, so I cannot continue. Maybe Google is having some issue, or maybe some other API which I'm using that is having some issues. So I cannot test my development. I cannot proceed for my development. So this is a problem over here. So that's why here the disadvantage of test-driven development is can be built only at the end of the development. So uh, in the next slide, we'll show you the example also. So basically, this integrated test, let's say maybe I'm working on component A and component B, but since these components are dependent on other further C, D, E, F components, which could be our component or maybe external component. So that's why we cannot proceed with this kind of testing until it is finished. Complex setup for the environment. So in this case, maybe we are using some specific kind of database or some third-party APIs where we need some complex setting, and all those kind of things are needed. So setting-wise, it is also very complex. Then a long-running test. So since we are integrating with the multiple component, maybe let's say this particular API is responding in 2 seconds, and this API is responding in 1 second, and maybe this is responding in 1 second. So maybe overall, if I'm calling this one particular API call, it is taking maybe 5 to 6 seconds. So maybe I have some 20 or 50 scenarios, then maybe for 50 scenarios running, it can take maybe around 200 to 300 seconds, which is maybe a 2 minute to 3 minute, which is time taking. Basically, ideally, it should do the job very fast. So that is another challenge over here. Then high effort to analyze the error. So let's say maybe we are getting error on at this component layer. Then, but since my call is starting from here, so first I will check over here. Is there any error? Maybe I'll go to the log and okay, I figured out logs look good. And it is when calling the B, that time error is coming. So then I'll come to B component. I'll check, okay, all the logs look good. And then I'm seeing, okay, error is coming from C. Then I'll come here and I'll check, and then I'll see, okay, error is coming on the D. Then here, when I'm seeing this log says, oh yeah, there is some issues. So that is how it is. It is very difficult to analyze the error very easily. We cannot analyze it. Fragile means it can break any time, because if it is this component is not available or not working, then it can break. It if it is not available or not working, then it can break. So anytime it can break. Then high maintenance cost. As I said, like if you want to maintain anything, then it is high maintenance cost, because you have to start from A, B, C, D, like that. You have to proceed. So this is a challenge. And the example given over here is like when we are making any aeroplane, right? So in case of that airplane, we cannot make airplane completely and then we can try to fly it. We should test each component, engine separately, and then other components separately, maybe the dashboard or whatever is the electrical equipments are there, whether it is functionally or not. All these things we have to test separately, and then we have to integrate and make a complete airplane, right? So that's why integration test is not always a good choice. So then what is the solutions? So we have a solution is a unit test is a solution where what we do a individual component, we take individual component and then we test it. So uh, when we are preparing unit tests, when we are starting our development, if I'm developing component A, so unit test will be written with that. If I'm developing component F, then the unit test will be written. So each component is tested separately, and then integration is happening isolated from the environment. So A is not associated with B, and C is not associated with B when we are testing C. We are testing independently. C is not dependent on D during the testing. So that is called a mocking. Then this kind of test is very fast because if I'm testing A is not dependent on B and C and D and E, F. So each these components are taking 2 minutes, 2 seconds, 1 second, and 1 second like that. So since it is not dependent on these components, so it is very fast. Then error analysis is easy. So since I am running the test for the component A and there is some failure, let's say I gave an example of airplane, right? So in case of aeroplane, if there is the issue on the dashboard when I'm testing a dashboard or when I'm testing a engine and there is some issue, so I'm very clear, okay, there is a issue on an engine. But if I'm trying to fly the aeroplane directly and it is not flying, then I'm not sure whether engine is having some not a proper thrust, or maybe some electrical equipment is having some issue or what. So I will have to check each and every one by one. But if I'm checking individual component, okay, whether electrical component is working fine or not, and I got, oh yeah, this is not working because there is some error. So maybe then I understand, okay, this component is having some problem and I have to test this component. So this is how error analysis is very easy, stable, and low maintenance. So this kind of testing is very stable because when we are completely mocking rest of the component, so it is giving almost every time similar result. It is not like, let's say maybe in the previous case, if we are storing something on a database and maybe that data is not deleted or not cleaned, and second time I'm running the tests, let's say maybe I am querying how many employees are there in my database, and some logic is cleaning up every time when I'm completing the database. So I'm expecting it should create my logic should create only one employee, and then maybe I'm also going on the database and checking whether one employee is there or more employees are there. So it should give me one employee. That is my expectation. And once test is running, then it should clean the database so that next time I'll run the test, it should give me one employee only. But by chance my test fail and something goes wrong, so database is not clean, and now I'm creating a new employee. At that time, now if I'm fetching the data from the database and database is giving me two employee, so my test is unstable. So these kind of scenarios are possible. So that's why I'm testing separately. No need to put data on database. I'm testing each component separately. And then since we are doing with the small component of maintenance wise, it is very easy. Disadvantage, run the test in simulated environment. Like here, no real database, or like when we are, in case of airplane, we are testing the thrust is, we are tested on the simulated environment, okay, by running that engine, and we are assuming, okay, this much thrust it is producing, but we don't know like whether it will be able to fly the plane or not. So this is a disadvantage. Then mm, why tests need testable when we are writing a test, so it need a testable code also. We cannot write test on a after writing a complete productive code, or without writing code. So there is some testable code is needed. And for testable code, there are like a decoupling is one of the scenario. We it decoupled product code. So basically whatever code we have written, it is decoupling, and then you can write a test for the isolated environment. So let's say I am giving example. Let's say I am creating a product in, or maybe I am searching a product in Amazon. So when I'm writing maybe I want to buy a mouse, or maybe I want to buy a laptop, when I'm searching it, it is going through multiple components. It is going to the controller, and then it is going to service, and then go service is calling the data access object, and then data access object is calling finally the database. So this kind of pattern, and then maybe there could be more complex pattern is possible. So as I gave example, there are three classes involved. What we can do, we can decouple. So maybe we can test controller separately, service separately, data access object separately, and database call separately. So this is how we can do it. I'll show you maybe one example at the end. Then refactoring is also important. So refactoring is a process of changing a software in such a way that it does not alter the external behavior. So maybe initially when we are starting, we are writing code in a very big method, that is possible. But then over the time, we had to refactor. Ideally, your method should be whenever you are writing any code, whether whatever is a language, whether it's a Java, C, C++, Node, or anything. Ideally, this code should be visible on a screen. So one method, if I'm writing, it should be visible on my screen. I should not do a scrolling. So you start writing the code logics, and then you realize, okay, now because of the requirement, my method is increased from it is going above or below from my screen. So then you should refactor. So create a separate method one and then call that method in spite of writing all the logic over here. So maybe just example, you are doing a validation logic, then you are checking whether that data exists or not, and then you are putting it in the database. So these three calls you are doing. Initially, you are maybe whoever has given a requirement, they said you just do a validation. So you did a validation, and validation logic was maybe a 50 line of code, which is visible on your screen. Then you have to pull the data from the database to compare with this data. So when you're pulling the data from the database, that logic you have written, and it is again 30 lines. So now it is not invisible on your screen. So for that, maybe you can create another. Initially, you have written that is fine, and you tested it. Okay, it is working fine. But now you refactor it. You bring that database call in a different method, and then call that method inside of the previous logic. So that is called a refactoring. And then clean code. Clean code always looks like it is written by someone who cares. Why it is important? Because it is not whatever is developed by me. Maybe I will be there for a development only, but then it will be maintained by someone else. So if I'm not writing clean code, then maintenance will be very difficult. Maybe they are not able to understand. Let's say maybe uh, I want to get the employee name. So, or set the employee name. So I have just written e dot n, and employee dot ID is e dot I, and employee dot age is e dot a. I have, when I'm writing, I know, okay, E dot N means employee name, E dot A means employee age, and E dot I means employee ID. These things I'm setting. But maybe tomorrow I'm not in, as a part of this team who is developing or maintaining that code, and new guy is coming. It is very difficult for him to understand what I have written. So ideally, basically, we have to write a clean code which is easy to understand. So in place of E dot N, I should write employee dot name, employee.id, employee.age. So these kind of variable we should use. So this comes under clean code. Always the name of the method or any variable should be very easy to understand. It should look better and anyone can understand. So that is the idea behind that. So there is a Mazzaro has written a very uh, good code. If the tests are good, then the product code is probably good enough. So if you are writing good test cases, unit test cases, then your product quality will be good. If tests are bad or do not exist, then all hope is lost. So uh, generally in SAP, when we are using any library, which is an open source library, or maybe any framework we are using, let's say maybe if you guys are aware about Spring or Express.js or maybe Struts, React.js, all these framework, right? When we are why we are using, why we are trusting, because they have provided test cases. With that test cases, we can easily test them whether it is working fine or not. It is covered by the test cases, so that's why uh, the trust is more. So that's why test is a very important, keeps very importance in the product development. Okay, so when we are doing a unit test design, then what are the tips and benefits are there? So unit test design tips and benefit, what cases to cover? That is the first scenario. So when we are writing any test cases, we had to consider positive cases. Let's say maybe I want to create a calculator, just example, which I will cover in one of the code also. So let's say I want to create a calculator, and in calculator, I need a add, subtract, multiply, and divide. These are the different functions are there. In multiply function, my positive case is when I'm passing a number to number, it should multiply and give me a result. if I'm passing negative numbers, then it should multiply, and based on the negative numbers, it should do a plus sign or minus sign. So two negative numbers, then it should give me positive result. If two minus, sorry, one minus one plus, then it should give negative result. So this is mm, positive case. What should be a negative case? Negative case could be if I'm multiplying one with a zero, or any number with a zero, it should give me a zero result. So this could be a negative. I'll in multiply case, I cannot say this is a negative case, but maybe negative case. This is there is no example, but negative case could maybe, let's say you are passing. I'm expecting this calculator should mm, only multiply the integer, but you pass some float value or maybe double value, right? So in that case, I do not want to multiply. I want to give some exception. Please pass the integer number. So this could be a negative cases. Then maybe when I'm passing 1.5, it should give me exception. Please pass the positive number, or sorry, please pass the integer value only. So this could be a negative cases. Then boundary value and their proximity. So for in case of a multiplication, you cannot pass any infinite number, because in my calculator, I have to also store. So maybe again, it depends on what kind of calculator you are developing. But let's assume I do not want to show exponential value. I want to show a full value. So then computer is having some limitation, and we had to consider, okay, you cannot multiply this big number because it will generate this much of the value, and which is a very complex, which we cannot show on the screen. So maybe that could be your boundary cases. Or maybe when we are asking for developing a calculator, maybe I can ask from my product owner, what is your requirement? Shall we, if we are passing very big number, then also it should calculate whatever is a number, or there is some limitation. So maybe they can say, okay, you can pass any number and multiplication should work, and whatever result will come, it will represent in form of exponential. Or maybe your product owner can say, oh, no, 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 I want up to 10,000 digit, up to 5 digit numbers only. So these kind of requirement could be a boundary conditions. Then combination of input values. So do not, when you are testing your test cases, do not test with only by passing, let's say maybe 3 and 5. You pass a multiple combination, 3 into 3, and one test case, you can pass input as a 3 and 5. Another case is 3 and minus 5. Another case is minus 3 and minus 5. And another case can be 3 and 0. And then maybe boundary case, whatever is the boundary value, it is provided by your product owner. Maybe they are saying, okay, max value should be 5 digits. So maybe 9999 is a max 5 value, and multiply by 9999 my 5 value. So these are the different combinations should be there when we are testing our test cases. So yeah, so as I gave example, generally when some we are testing, we should test all the plus cases and minus cases. As in case of engine failure, right? In case of aeroplane, we had to see all the cases. If engine is not working, one engine can, other engine can be able to support, or what will happen if it is not working, or if this particular lever is not working, what will happen? So these kind of things are cases. If I'll continuously click multiple times, then what will happen? Will it fail? The switch will not work, or what? So this is a case to cover. Then uh, tips, sorry. Then next is a tips and tricks. So when we are testing, there are a couple of tips and tricks are there. We should write our test class name shall express the given, or the when semantic. So let's say maybe I am saying a calculator test. So we understand, okay, calculator is given and we have to test that calculator. And then on that also we should provide what is given. So we have given calculator is given, and when semantic can say like when calculator dot multiply is called, then I have to return this as a result. That kind of thing we can teach our unit test. However, we are not going on that complexity for this session. Then test method name shall represent other part of the test story. So let's say maybe I am testing a multiply method, right? So then your test set say test multiply. That should be the method name. By reading that, you can understand, okay, this is going to test the multiply method. Name the code under test always cut. So basically, your name should be the test cases name should be as per whatever method you are testing, as per that. As I gave example, multiply. If you're testing multiply, your name should be test multiply. You should not write test divide because you're not testing a divide function. You're testing a multiply function. Group test in a test class by same setup or same code under test. So maybe if I'm testing a multiply with the all positive negative boundary cases, then I should be keeping it on same class. Then maybe divide is also part of the same calculator, then I can keep that also. So you can group in a class like that. And then test method tell a story, short and crisp in less than one screen. So as I gave example, your code should be visible when you're writing test cases. Also, it should be visible in screen. One test cases should be one method for the test cases should be visible on your screen. If it is extending from your screen, right, then create another method on from and call from your test method, like refactor it in section of given, when, and then. So when we are writing, there should be a given. So what is given? You have a calculator class is given. And when in calculator, when I'll pass maybe 3 and 5, then I'm expecting 15. That is my expectation. Another tips and tricks are there. Test only the public interface, not a private. Sometimes like some tools are there which support to test the private function methods also, but that is basically that is bad practice. Ideally, that is needed if you are testing after writing complete code. Idea is to not write complete code, just test the each component. So whoever is designing, let's say maybe engine, they are testing engine separately. Whoever is designing the dashboard, they are testing that electrical dashboard separately. So you do with the component. One test method tests one test aspect. So like one test method is test one aspect. One aspect means one test method should not test all the scenario, positive, negative, boundary, and combination test. One test method is only for test positive, one for negative, one for boundary, one for combinatory test. Again, that is not a one for a combinatory, but again, if you want to test for a negative value passing, then you can have one more test. So that is how it should be. Uh, First paradigm. So first means your test should be fast. It should run very quickly. It should be independent. So maybe let's say calculator service is there and it is calling calculator function. So then it should be independent. Calculator service should run independent of calculator. I'll show you example. Repeatable. When if I'm running the test n number of time, it should give me the same result. Then self-validating, pass or fail. So in our test cases, we should write a valid function, whether it is validated or not. I think couple of guys are raising hand. Maybe I'll come at the end. We can come back and I can come back on the slide also. Then timely write test case with the product code. So whenever I'm writing a product code, then together we have to write a test cases. Refactor test at least as good as product code. So like as I said, gave example, right? If you are doing some different behavior, going away from your screen, then just refactor it. Or maybe a same kind of code is used in all the test cases. Let's say maybe you are writing one test case for a positive, one for negative, one for boundary case. But in the all these test cases, you same logic is applied. Couple of logic line of code are same. Maybe 5 line of code are same. You can keep it in a separate method and directly call that method from your positive, negative, and boundary condition test cases. Refactored, okay. Then keep it stupid and simple. KISS principle we had to apply. So your it should be very small, very simple. Don't repeat yourself as I gave example. If 5 line of code is called on all the method, then you in spite of that, you can create a separate method, keep that 5 line of code and call that method on all the test cases. So that is how we should do it. Then benefit of unit tests. So there are a couple of benefits are there. First is the confidence. So when we are running our test cases, test create a safety net. So how it create a safety net? Basically, in future, someone will come and want to change your code, right? They can first test, okay, how it is running, and then okay, there is new requirement come. So after adding that new requirement, they will test it again and they can see whether my previous functionality is breaking or not breaking and what is happening. So it provide a safety net. encourage and enable changes. So with this, you can confidently change it. Let's say maybe I'm telling one of you guys are joining my team and I'm telling you, okay, you just change something in this particular method, and your change is coming. Let's say maybe my method is a 50 line of code, and your change has to come at 25 line number, 20 in between 25 and 26. Then what you can do, you can move that line number 25 and 26 to another method and run the test cases first. What was already there, it should still working properly. You just move that code. Now on the moved code, which you have created a new method, on that you just add your logic, because it is just a 2 line of code or 4 line of code. On that you add a logic and write a test case for that separately and see whether things are working fine or not, and adjust the test cases accordingly because you have new functionality is added. So this will give a encourage for the changes. Better code quality, consumable API. So as I gave example, if you're writing a library or API which is you are putting on github.com, then if it is uh, it is providing the quality of code, if it is all the scenarios are covered, then uh, uh, it will be, anyone will be confident to consume it. Decoupling will be there. If you are writing a code better way, then obviously one component can be tested without other components. So the decoupling will be there, proper decoupling will be there because you can test it very easily. Testability is there. Maybe you, since you have already written test cases, anyone can test anytime very easily. Less maintenance effort because you have already invested time to write it. So in future, if I'm going to change anything, it is very less maintenance is needed. Living documentation. So when we are writing a test, it is a basically all the scenarios are covered. So it is kind of a living document. It is a providing a executable specification. So as I gave example, okay, for multiplication, I can pass minus, minus, and plus, plus, and minus and plus, and then what are the things that are going to be happen by anyone can go to test cases and then they can see and understand. Test document the API usage, like how to call the API, like let's say calculator dot multiply, how to call that. So that information we are getting it. Test codify the requirement. So as I gave example, like multiply is one of my requirement where these are the scenario positive, negative, boundary cases are there. So by seeing that, anyone can get the information. Debugging, let's say maybe I want to check, okay, someone is saying ki your class is throwing some exception when I'm passing 3 and 8. So in that case, maybe I can go to my test cases. Maybe in the test cases, calculator service is coming in picture, then calculator is coming in picture. So first, maybe I can test by passing 3 and 8 in the calculator service, and I can see whether it is working fine or not. Yeah, it is working fine. Then I can go to calculator class, and then I can test it. So this is way I can test by passing and debugging, and I can figure out, okay, in this class it is breaking, this logic is not working. So this is how we can debug it. Then, okay, so now I talk a lot about test-driven development for feature and functionalities, how we had to do it. So when we are writing test cases, I don't know you guys got exposure to write any test cases or not, but test cases, there are frameworks. If you're using Java, then JUnit is a framework. In JavaScript, there is a different framework is there, which is called JMock is there, and then CNAN, Mockito, all different tools are there. So Jest is there. So different frameworks are provided to make your life easily. But you can also write on the same technology or test cases. So how to write a test cases? Basically, let's say maybe I am your product owner and I have given you requirement. You have to prepare add function in a calculator. So then that is one requirement. Another requirement, you have to add subtract function. Another requirement is you have to add a multiply function. Another requirement is you add a divide function. And then I said, okay, there should be a service and all those things. These are small multiple requirement. So you started with the first requirement. Okay, add function. You started with the add function. Write a test code. So first we had to just create a calculator class on that add method. In add method, I am passing two variable only, and then to it should give me initially, because do not have to write a productive code. So I do not have to write a logic key how I have to do addition. You just create add method and two variable, and then it should return some value. So initially, since there is no logic, so it will return zero because integer should be returned. It will return a zero. Now I have to write a test cases for calculator tests as a class and test add method. So test add method will test the calculator. So in calculator test, so we'll create a calculator instance and then we'll call calculator dot add. When we are calling, my expectation is in add method, if I'm passing 3 and 5, my expectation is it should return 8. That is my expectation. But when I'll run my test cases, it will fail because there is no implementation. I'm just returning 0. So now my test case is failing, but syntactically, compile wise, it is correct, but logic is not there. So my test is failing. Now I had to write a productive code. So now I'm writing a productive code, which is A plus B, written A plus B. And then as a result, my test case is passing. But maybe if it is a big code, let's assume when I'm writing a logic, it is going more than a 50 line or 100 line, or which is not fit on the screen, then maybe I'll refactor, I'll create it two method. And one could be obviously private method. And then this one add method is a public method. So in that public method, I'll call a private method. That could be a possibility. So refactoring I'll do. And then again, test not complete. If my test is not completed, then I had to uh, mm, repeat it again. And if it is pass, then I had to ship it as a code. First, I had to check whether test is completed or not. So there could be many tests, and all tests are completed or not. Once test is completed, then I had to ship that code. So now test is complete. So for addition, I can have multiple cases. One, when I'm passing, I'll write test add with positive number 3 plus 3 and 8. It should return 11. Another test is 3 minus 8. 3 and another value is minus 8. It should return minus 5. Another could be 3 and 0. It should return 3. I added 3 and 5. Minus 3 minus 5. So it should I'm expecting it should return minus 8. So these are the four test cases I have written. All test cases are passing. So now I can shift the add function. Now I'm picking another requirement and I'm working on another requirement. Or maybe your product owner can give on the add only. He is saying, okay, now in add you can add, I can pass multiple values. In spite of two, I can pass multiple. Then again, your test, your test, you'll update your test. Okay, you will pass multiple, and maybe you'll adjust your method. Maybe I can pass multiple. But since you're passing multiple, but you have not done any code change over here. So let's say I'm passing 1, 3, and 5. And then from the test method, I'm expecting when I'm passing 1, 3, and 5, I'm expecting it should return 9. But so you added a test add functionality. The next is your subtract functionality you are developing, and then same thing we have to follow. I'll cover it quickly by showing you a code. Then, so what is the benefit of test-driven development? So test-driven development feature. So basically, it drive your feature development. As I gave example, right? First, maybe you're developing a feature called addition. So maybe first requirement is okay. You just give me a addition function, and then now I develop a calculator. And when you're going on my site and when you're adding two number, addition is coming. Next, maybe I'm giving a subtraction. Next, I'm giving a multiplication. So one by one, we are providing it. So it help on the feature development. Focus on the essential. So basically, test code. Focus on essential. So basically, test codify only the requirement. So basically, generally, what happens when we are writing a test cases, right? Sorry, when we are writing a code, sometimes it happens like maybe my product owner has given some requirement, or maybe I started developing something, and then I'll feel okay. Let's keep this code because it will be needed in future. But when you are writing a test cases, right, when it is a compulsory to write a test cases, then generally we focus only whatever is needed. We are not writing unnecessary code, because if something is sitting on my productive code, then I need to write a test cases. And that's why it is encouraging me to write only necessary productive code. Test. the tests were seen red once and then switch to the green. Basically, I gave example, right? Initially, I'm writing a test cases which is a red, and then I added a code for addition logic, and then now it is a green. Product code is testable by design. So testable by design means, so when I am writing a product code, it is by design, it is tested. If I am writing a addition code by design, it is a, because I am writing a test cases. So it is a testable. Bug were introduced just now and can be fixed right away. So if I'm writing any bug, like a bug means I can say I'm just initially I was adding a two number, now I pass three number. So this is kind of bug for me because it is not solving, not supporting. So now I can fix it very quickly. Okay, my test case is saying, okay, this is not giving a wrong result, failing. So now I can go and I can change the logic, and then my test case is returning a correct result. Product code start with simplest code needed right now. So first we start with very simple code, and then maybe slowly we are increasing the complexity. Here I have created a calculator class, and maybe my product owner gave me a requirement. I need a calculator class. On that, I want addition add function, subtract function, multiply function, and divide function. So I just write a very bare minimal code. It is in Java. I have written very bare minimal code, and I just written a return is a zero because I have not written any logic. I just written as a zero everywhere. Then maybe he also told me I am calling this from a service class. And in that service class, I'm creating two methods. One is a multiplication of addition and subtraction. So basically, my product owner is saying ki if I am multiplying a addition of two number and subtraction of two number, let's say 3 plus 5 and 5 plus 3 and 5 minus 3. So 5 plus 3 is 8 and 5 minus 3 is equal to 2. So 8 by 2, that kind of thing I want to do. That is a requirement given by my product manager, product owner. So for that, he told me to write a logic. So I thought, okay, I have already created a calculator class. So I will use that over here in this class. That is what is my expectation. And similarly, he is saying, okay, similarly, addition of two number and divide with the subtraction of the two numbers. So I'm passing 5 and 3. So 5 and 3 is equal to 8. And subtraction is 5 minus 3 is equal to 2. So 8 minus 2, 8 divided by 2. So I'm expecting 4 in this case. And then also a boundary condition is if I am passing the number is like a subtraction is 0, then I should not I should give some arithmetic exception. Basically, I have to say this is not allowed. So you're dividing by 0. So I'm giving some error. So this kind of scenario he has given to me. So now as you can see here, I have not written any implementation. I just defined two number and let's say that's two numbers. Sum is 0 and sum difference is 0, and multiplication of sum and difference I'm getting over here. Similarly, sum is 0 in case of this, and difference is 0, and then I'm just dividing this. This kind of logic I have written. So first, since let's assume one guy is in my team is working on this class, and another guy is working on this class. So first another guy will create this much only and provide that code to the uh, pushed in somewhere centrally so that this guy can pull it who is working on this, and he pulled it and he also written his logic. So now let me quickly test this and I'll show you. So I have written a test case for the calculator service test. So what this calculator service test is doing, first, I'll create a in this test class. This is a calculator service test class. In this calculator service test class, I have created an instance of calculator service, which is this. And here I have to pass a calculator. Okay, I do not have to pass calculator over here, so no need to pass this one. Sorry. Uh, yeah, this is not needed. So I have created this service, and this service class is this service class I am calling multi. Oh, sorry, there is some spelling mistake. This is a multiplication of addition and subtraction. So basically, here I am calling this particular method. Right now, there is not complete implementation. Right now, I have not written a productive code. So let me run this test and see. So what I am expecting a set equal to 2 plus 3 is 5 and 2 minus 3 is minus 1. So as a result, I'm expecting -5 because the multiplication of -1 and 5 is -5. So let me run this test and I'll show you what is happening. So test divide by 0 is working fine because I am already throwing that exception. Ideally, I should also not throw, but this is working fine. Test multiply, which is this method, this is not working. So as I said, test should fail. And this is also failing. Here I am dividing 6 plus 3 is 9 and 6 minus 3 is 3. So 9 by 3 is equal to 3 should come. Uh, mm, but this is failing. It is not coming. Why? Because there is no implementation. So when I'm passing this value, nothing is happening. It is 0, 0, 0, always 0. So now, uh, next step is maybe uh, I will do a I will do a logic change over here. So let me write a logic. So and similarly here, A plus B and A minus B. So now my logic is complete. But if you will see, oh, sorry, I did a mistake. In that I'll use directly calculator. So I'm passing same value in calculator dot add function I'm calling, and I'm passing A and B. So whatever value is coming on A and B, I'm there. Similarly for difference, calculator dot subtract and A and B. And same thing I'll do there as well. So let me directly copy and paste. And now you can see I'm doing it. If I'll go to the calculator class and I'll show it is returning 0. So if I'll run this again, you can see it is still failing. But so now I'm completely dependent on calculator class. So this is a kind of integration test because I'm completely dependent on calculator class. So that's why I have to do some cooking. So what I did over here, okay, I did something wrong over here. I had to pass a calculator uh, basically, and okay, this is creating a calculator. Oh, sorry, I have created another one. Yeah. So this function I'm calling, and now I'm passing a calculator. But as you can see over here in this line, what I'm doing, I'm just creating a mock object. This is called a mock. Obviously, you will not understand maybe on that deep for now, but just giving you example in Java and even similarly in other languages also these kind of things are possible. So yeah, so let me test it once again. Calculator does class when this is passed, then return 5 because calculator is a null. Okay, sorry, I did a mistake over here. Now you can see this code is green. If you'll see in calculator class, nothing is implemented here. But in service class, what I'm doing, I'm passing A, B, and then sum is coming and then diff is coming. So basically it is calling my calculator function, but in calculator there's no implementation. But then also my test is green. It means this whoever is writing this code, he is not dependent. He is just asking for syntax. You just create a array function and all, and I'll mock you. And I'm passing, when I'm passing 2 and 3, the addition is happening. 2 plus 3 is equal to 5. And then 5 is happening. So here I'm teaching it. This is when I am passing you 2 and 3 calculator, then you return 5. When I'm passing 2 and 3 calculator, then you return -1. That is what I'm teaching. And then I'm calling a real function of my service class, service dot multiplication, and I'm passing 2 and 3. So this is a mock object. That is called a mock object. It is returning this value. Without implementation, I am independently running this. So basically, I'm independently testing it. That engine I'm testing independently without the connecting with the laptop. Sorry, without connecting with the aeroplane. Similarly, for this, I have also another test. And if I'll run this test, right, all the test cases are failing for sum function and subtract function, multiply and divide function. So all these things are failing because I have not written any implementation. And if I'll write implementation, so now I have written an implementation, and if I'll run it again, this is also running fine. So this is how we have to proceed whenever we are writing the test cases. So as you can see, right, I have first written the test cases. Now I have not changed the test cases. I have changed only the productive logic. So this is how the test cases, test-driven development happens. Yeah. So with that, this topic is over here. Maybe if anyone is having any question or query, then let me know.
So, Madhusudan, we have one question from a scholar. Like it is related to the
Yeah.
reliability of the test, like how to measure the reliability
Mm,
of the test. If you are getting a good code coverage, then it is good to go
mm.
on. Basically, when we feel that it is okay, we can move along with the code that we have developed.
No,
Yeah.
there is a generally in our project we have some standard like it should be above 85%. So there are some tools are there which calculate your code coverage. This I think I don't know, this will not work because I do not have coverage tool associated with this. But it gives a code coverage, and with this code coverage, we can judge, okay, whether it is 85% or not. And based on that only, so here you can see, uh, ideally, actually, I had to ignore these test cases also because I do not write to cover test cases. Basically, I had to cover my logic. So as you can see, this since I am running only individual, maybe if I'll run complete one, then it will give me a coverage. So
Yeah, thank you. Thank you for answering
okay,
that.
Jay, you had,
Yeah.
yeah,
So with
yeah,
that, we
and then
comes to the end of the session. So I want to extend my sincere gratitude to the time and insights you have shared today, Mr. Madhusudan. And your depth of knowledge and
thank
real
you.
world examples, I'm sure it has brought a lot of clarity and inspiration, making it truly definitely an enriching experience. I know we also face a little bit technical glitches, but we are so glad you were patient and you were with us
Yeah,
throughout.
there's some, yeah.
Yeah, that is not an issue, but we are truly happy you are there. And a special thanks to SAP team and FFE family for your smooth coordination and support that made this webinar a success. And to our scholars, definitely thanks a lot for the patience and participation and active engagement, which has made the session meaningful.